Hi, I'm Michelle Sheran-Andrews, and in this video, I will talk about the graphing, the substitution, income, and total effects of a price change help sheet. Before reading this help sheet, take time to recall each of these concepts and definitions. This list is posted on Sakai. After reading this help sheet, make sure you understand its concepts by explaining and identifying each item on this list. Now let's get some practice applying these concepts by working through this problem. Here we have Rick, who purchases fast food and clothing. The price of fast food decreases, and we need to graphically depict the total, income, and substitution effects of this price change. Let's first assume that fast food is a normal good. For all three cases, we also will assume that clothing is a normal good. The first step will be to graph the three budget lines. Budget line 1 represents Rick's initial budget line before the price of food falls. Budget line 2 represents his new budget line after the price of food falls. And the compensated budget line is a mechanism we need to add in order to decompose the total effect into the substitution and income effects. When graphing these effects, put the good whose price changes on the x-axis. Here's the original budget line. This line represents the initial price of food. Here's the new budget line. Since the price of food falls, BL2 rotates out away from the origin. The compensated budget line must have the same slope as BL2 and must cross BL1. This budget line represents a hypothetical. Hypothetically, what if we allow the slope of the budget line to here fall? What if we allow the relative price of fast food in terms of clothing to fall, but we undo the increase in purchasing power that also occurs? One more time, we allow the budget line to rotate to reflect the new MRT, but we shift it to undo the change in purchasing power that also results. The second step is to construct a chart. This chart will show the substitution, income, and total effects on both fast food and clothing. In this example, the price of fast food goes down. This causes the relative price of fast food in terms of clothing to fall, inducing what we call a substitution effect. The substitution effect always will have the consumer, here Rick, substituting towards the good whose relative price falls and away from the good whose relative price increases. So in this case, because the price of fast food falls, its relative price, or its opportunity cost, is lower, which makes Rick want to buy more, substituting towards fast food and away from clothing. At the same time, when the price of fast food falls, Rick feels richer. His purchasing power increases. This induces an income effect. In this first case, both fast food and clothing are assumed to be normal goods. So when Rick feels richer, the income effect is for him to buy more of both goods. Putting these two together, we get the total effect. Now, for fast food, the total effect is unambiguous. He both wants to substitute towards fast food because its opportunity cost is lower, and he feels richer and fast food is normal, so he wants to buy more because of that too. The total effect on fast food is necessarily for Rick to buy more fast food. Clothing, on the other hand, has an ambiguous total effect. On the one hand, he wants to substitute away from clothing, but he wants to also buy more clothing because it's normal and he feels richer. Which of these two effects is dominant will determine the total effect. But here we don't have that information, so I'll leave it as uncertain. The next step is to place three consumption bundles on the budget lines. Consumption bundle A is the original chosen bundle. That's the bundle that Rick actually chooses before the price of food falls. Bundle C is the new chosen bundle, the bundle he actually chooses after the price of food falls. So, movement from A to C represents what actually happens or the total effect. B, remember, is a hypothetical. Hypothetically, what if we start at A, we hold utility constant, and we allow the relative price of food in terms of clothing to fall? What if we allow the relative price of food in terms of clothing to fall, but we don't allow purchasing power to change? That's the substitution effect. Now, the income effect is from B to C. From B to C, purchasing power is changing, but the relative price is not. We're not allowing the relative price to change, but we are changing purchasing power, making this the income effect. Now I need to place these three bundles on the budget lines. A must be on BL1. The original chosen bundle must be on the original budget line. C must be on BL2. The new chosen bundle must be on the new budget line. And B must be on the hypothetical budget line called the compensated budget line. I've got to be careful with my placement of A, B, and C relative to each other. From A to B, food must go up and clothing must go down. A is on BL1, B is on the compensated budget line, and from A to B, we have food going up, move to the right, and clothing going down, so move down. From B to C, the income effect must show both food and clothing going up. So I need to move to the right so food goes up, and I need to move up so clothing goes up. Here I've achieved that. From B to C, food goes up and clothing goes up as indicated on the chart. Lastly, the total effect from A to C should show food going up, which in fact it does. And on my graph, I have clothing going down, which we knew was a possibility. The final step is to add indifference curves. All three of these bundles are chosen bundles and so points of tangency. A and B are by definition on the same indifference curve. So A and B are both on IC1, where A is a point of tangency to BL1, and where B is a point of tangency to the compensated budget line. Now we want our graphs to look good, but let's not sweat small little imperfections. So for example, here you see that my bundle A is not quite on my indifference curve. I'm going to use a method I like to call the big dot method and just increase the size of this dot so that now to the reader of the graph, it does appear to be a tangency. And you can do that too, of course, within reason. All right, IC2 is going to be the indifference curve that bundle C is on. So C is a point of tangency between IC2 and BL2. It's important that all three of these bundles are points of tangency. That's the number one thing that people mess up when doing these graphs. So with that in mind, let me show you something. A and B always have to be on this outside portion of BL1 and the compensated budget line. Said differently, it's never going to be possible for you to put B here or A here and still have them both be points of tangency, which they need to be. So make sure you never try to place A or B in the purple shaded region, instead always placing them in the yellow shaded region. In the purple region, what you're going to see happen is that one of your two bundles will not be a point of tangency. Now let's look at case B, where fast food is an inferior but not given good. Because fast food is an inferior good, clothing now must be a normal good. Both goods cannot be inferior. The budget lines will be exactly the same as the first case for the very same reasons. The chart will be different. The substitution effect is the same though. His income effect, however, is now different. He feels richer, but fast food's inferior, so his income effect will pull fast food down. Clothing is normal, so his income effect will pull clothing up. In the case of fast food being inferior, now the income and substitution effects are pulling fast food in opposite directions. We know what happens though because we're told that fast food is not Giffen. That means that fast food obeys the law of demand. So what ultimately happens is that when the price of fast food goes down, Rick's consumption will go up. What happens to clothing, however, is still ambiguous. Now let me put these three bundles, A, B, and C, on the budget lines to show the directions of the movements that we see in the chart. Notice that the position relative to each other is different. Now C is the point in the middle, A furthest to the left and B furthest to the right. This shows what the chart says. From A to B, Rick substitutes away from clothing towards fast food. From B to C, he buys less of the inferior fast food and more of the normal good clothing. And from A to C, his consumption of fast food does go up. Last, let's put on our indifference curves. And now we have decomposed the total effect of the price decrease for Rick, assuming that fast food's inferior but not Giffen. In this third and final case, fast food is a Giffen good, which means it's an inferior good for which the income effect is dominant. So what do we see? We see the same budget lines as in cases A and B. We see the same substitution effect as in cases A and B. Case B and case C have fast food as an inferior good, so the income effect is the same as well. What's different here is the total effect. Because fast food is a Giffen good, fast food must break the law of demand. The price of fast food goes down, and the consumer actually wants to buy less of it. That means they have to buy more clothing. The graph is different as well. Notice that the placements relative to each other of A, B, and C are different. Now C is furthest to the left, A is in the middle, and B is furthest to the right. This graph shows the consumer substituting away from clothing towards fast food, according to the substitution effect. It shows the consumer, according to the income effect, buying less of the inferior fast food and more of the normal clothing, and ultimately from A to C, moving away from fast food and towards clothing. Now go beyond the surface of this help sheet by analyzing and evaluating. To help you with that, I've prepared a list of things to consider. Lastly, push even further beyond by creating. Work through each of these suggested items and take them to recitation to share and compare your answers with your classmates. This concludes the graphing, the substitution, income, and total effects of a price change video.